Hello, this is Ali Kotami with SCS Engineers. The subject of this presentation is surface water management system, swales and downshoots in funnel covers. There are many different ways to design funnel covers and the surface water management system in funnel covers. This is a system that we have been designing for the past many years. It's already part of permits for many facilities. A number of partial closure has been done in accordance with this design. It's a very effective and very efficient system, simple to construct, and easily brings water from the slopes to the perimeter ditches without causing any erosion or problems for the slope. Surface water management system components on landfill slope includes tack-on swales. This is for the case of no terraces on the slope, and this whole design is based on tack-on swales. The next item is the lateral chutes that we are going to discuss. Lateral chutes connect the tack-on swales to the downshoots, which is the next item down. We are going to discuss the construction of the downshoots, and then at the end we'll discuss erosion mats that go around the lateral chutes and the downshoots inlet and outlet in order to protect the area around these pipes. Downshoot pipes in the cover system are simple design. There are two pipes at each location. You can of course use one single pipe depending on the geometry of the slope, the drainage basin that leads to the downshoot pipe, and some other factors. And the length of the swales, of course, is another factor that comes into the picture, whether you need one pipe or two pipes. But with two pipes, here is the layout or detail of it. 5 feet apart pipes. They are 16-inch diameter pipes located directly on top of the geocomposite drainage layer of the funnel cover. And of course, geomembrane of the funnel cover is directly below the composite. This detail shows a 1 foot thick kind of grading layer below the geomembrane, and then protective cover that goes over the geocomposite, which is normally 2 feet thick, may vary from state to state. On the plan view, this is the layout of the downshoot pipes in the middle. It's kind of background color. And also connecting to the downshoots are the lateral chutes that are branching off, one from each downshoot pipe. The elliptical kind of a black line are the openings to the lateral chutes, and these elliptical openings are at the low point of each swell, one to the right, one to the left. And the flow line of these swells are normally a slope at 2%. The small ellipticals with a black arrow attached to them with a slope number in them is just slope inclination. So anything in the upper part of the page above the 2% notations are the landfill slope down at 3-to-1 slope. And on the swell we have 5-to-1 slopes toward the 2% flow line of the swells, and below the 5-to-1s are 2-to-1 slopes that extend some distance down the slope, and then they get converted to 3-to-1 slopes. We have incorporated this concept, this funnel cover concept, in many of the permits that we have worked on during the past many years, and we have constructed partial closures which included these systems in them on many cases. For example, the Okeechobee landfill, we have constructed 5 partial closures, 5 phases. Medley landfill 4 phases, Monarch landfill 6 phases, Naples landfill 1 phase, and all of them have this system in them. Just to pass on some field information to you, I'm going to use photos from several projects that we implemented over the years. This is one project at Moore North Landfill, and it is about 4 acres, 5 acres of a partial closure. To the right side of the slide you see the bottom of the slope, and to the left side is the upper part of the slope. This is a partial closure in the sense that a portion of the slope had reached final grades, and the client wanted to cover that portion of the slope. So that's why it is called a partial closure. Later on, when the landfill extends vertically up, going up in elevation, there will be another partial closure above this that would tie into this partial closure at a later date. At this stage in this slide, the surface of the slope is prepared. No geosynthetics installed yet. The upper part of the slope, which is to the left side of the slide, it is sloping with the low points and the high points in order to convey any runoff from higher ups to a low point of this partial closure. At the low points, we install the downshoot pipes, and the downshoot pipes daylight at the low point of this swell at the top of the partial closure. We'll refer to this swell as temporary swell, because at some point in the future, when the next closure gets implemented, these swells will disappear. But for this case, we have 2 low points, so we have 2 downshoots planned for this partial closure, which the downshoots extend down the slope and eventually drain to the perimeter ditch, which is the green area to the right side of the slide. That's a fairly wide perimeter ditch. This is not a normal size perimeter ditch, because as you see, there are high voltage power poles within this perimeter ditch easement. This is a special arrangement at this site because a utility company, that's Florida Power and Light, has a substation near the landfill, that the power lines go around the landfill and eventually go to the substation. So we kind of reached agreements with the utility company many years ago to have pads across the width of the perimeter ditch for the poles to sit on, and the space between the poles will be used as perimeter ditches for the landfill. Now I'm going to present to you the tack-on swells on the slope, a simple graphical presentation of a tack-on swell. Here's the tack-on swell. The landfill slope is 3:1 at the geomembrane level. Above the geomembrane is a geocomposite drainage layer, and above that generally is 2 feet of protective soil that goes over the composite. But every so often in vertical distance we'll have a tack-on swell that gets constructed. This is a conveyance swell that carries, that receives runoff from slopes further above the swell and conveys the water to a low point within the swell system. And the shape of the swell is generated by creating a mound below it, which is the tack-on berm. The outside the slope of the tack-on berm is 2:1, merging into the 3:1 further down the slope. Over the swell area, the upper side of the swell is the landfill slope at 3:1. The left side of the swell is a 5:1 slope, and we normally make it 10 feet wide. The reason that we have such a large dimension, because we want to make sure that the equipment that will be used in the future to maintain the system can operate within it. The swell is normally oversized for the surface water runoff that can get in it, but because of the constraints on the dimension with respect to maintenance equipment, the client agreed to have 10 feet dimensions on the side for that purpose. Now I'm going to go through some slides from construction events for the construction of swell. Here you can see the slopes. To the right side of that orange flag is the landfill slope at 3:1. To the left side of it is the 5:1 slope. of the swell, and the hump you can see is almost forming in this slide and going down at a 2-to-1 slope, blending into the 3-to-1 slope of the landfill and slope further down. Here's the equipment that is shaping the slope. To the left side of the equipment is the typical landfill 3-to-1 slope. The 5-to-1 slope of the swell is between the bucket and the body of the equipment, and to the right side of the bucket is a 2-to-1 slope, blending into the 3-to-1 slope further down. Here is during the construction, we make sure that the contractor shapes the swell in a proper way. So this is one way to make sure that the width of the 10-foot 5-to-1 slope is created in the field in terms of the depth of the swell, which is about 2 feet deep at the directly above the flow line. They have to meet that. So it's in the midst of shaping and forming the swell. Then the surveyors come on site. They check the 2% flow line of the swell, and the shape of the slope, whatever it is that we install the cover system on it, they slope or they stake the slope 2% to fit the shape of the slope. We don't normally require grading of the slope to a perfect 3-to-1 or very geometric shape. We normally work with whatever slope it is there, and then we build it 2-to-1 slope, 3-to-1 slope, 5-to-1 slope, and the 2% flow line fit the shape of the slope as is. Again, here they're getting to the final shaping of the swell. The stakes mark the width of the 5-to-1 slope, which is 10 feet. The dozer is shaping the flow line of the swell. Again, the surveyors check the width of the 5-to-1 slope, which is supposed to be 10 feet, in addition to the 2% slope for the flow line of the swell. You can easily see in this slide the slope that the swell has toward the forefront of the slide. The stakes reflect the width and the location of the flow line and the hump in the swell. And further back, they are still working on some components of the swell system. Here is pretty clear that this portion of the swell that is in the forefront of the slide is pretty much finished. Where the two fellows are standing, the one to the right, is about the low point, is standing about the low point of the swell. And behind him you see the other side of the swell, which is sloping toward the low point. So the swell system is shaping pretty good in this slide. Again here you can see the two sides of the swell, one each at 2%, sloping toward the low point. Right in the middle of the slide there's the low point. The back side, the back area of the slide shows the 2% toward the low point, and the forefront of the slide shows the 2% toward the low point in the middle. This slide shows the end point of the swell. We shape the end point depending what geometry we have to deal with. And in this case, the 5-to-1 slope is already sodded, and the flow line is to the right side of the sodded area, flowing to the low point of the swell. Here is a kind of overall view of the project area, and there are two swells on this portion. The lower swell is shaped pretty good, and the low point is very clear in this slide, and sloping from the low point toward the high points. The forefront of the picture is another partial closure which was done some years earlier. Eventually the swells on the new portion and the swells on the old portion will kind of come together. there is a temporary lined chute between the new section and the old section that eventually will be removed. The temporary chute carries runoff from the higher part of the landfill toward the perimeter ditch, but that's a temporary system will be removed at a later date. In this slide, they are working on the upper swell. It is not shaped perfectly yet, but that's the process for shape. As the soil progresses over the slope from the bottom to the top, they gradually shape different components of it. Here is a later stage of that. Both swells are shaped and the slope is sodded, or majority of the slope is sodded. Now, the area above the upper swell is being shaped and formed, and there is a temporary swell at the very top of this partial closure. Of course, this partial closure is slightly different than the one I showed you earlier. This one has only one single low point where the downshoot is going to be installed. And now they're working, in this slide, they're working on the temporary swell at the very top of the partial closure. This is again is the swell. The slope below the swell is sodded. They're also working on sodding a portion of the upper slopes. The area at the low point of the swell is where the downshoot pipes are going to be installed. In this case, the contractor decided to build the entire swell system and then come back and excavate the soil on the composite right at the low point to install the downshoots. We normally leave the means and methods to the contractor. This is how this contractor decided to do it. So you see a kind of excavation at the low point of the swell. That's where the downshoot pipes are going to be located. Now, temporary swell at the top. I spoke about the temporary swell at the top. Now we are going to look at more details or more photos of it. This is where the upper end of the partial closure is. To the left side, the partial closure is near completion. To the right side is the landfill slope, uncovered, leading to the higher portion of the slope. At the forefront, where the flag is the end point of one of the downshoot pipes. This end point is a temporary end point. When we come back some years down the road to close the right side of this slide, which is the next partial closure, we extend this pipe further up as the continuation of the downshoot to the next swell and the further up swells. Where this termination of the pipe is, we create a slope in the form of a swell with a flow line sloping toward the pipe in order to catch runoff from higher ups, from higher slopes going toward the downshoot. This is the low point of the temporary swell. The two downshoot endpoints are visible here. The equipment and the crew is shaping the slope at this case. Again, to the right side is the landfill, uncovered landfill slope. To the left side is the partial closure that is near completion. Now we are going to discuss construction of downshoot pipes on the slope. One of the ways to construct the downshoot pipe is welding the pipe segments outside the project area. In this case, the pipe segments are already welded together outside the project area, and the pipe, as you see it, attached to the equipment is the full length of the downshoot pipes with Y couplings attached to the pipe at certain point. These are the lateral chutes that were measured from the design and the field conditions and placed in the pipe system at certain locations. After the pipe is put together, then the equipment pulls it over to the project area and pulls it onto the opening where the pipe is going to be installed. Here it shows the trench where the pipes are going to be located. And in this picture it shows that the equipment is pulling the pipe into the trench for positioning the pipe in the right location. And if you look carefully at the forefront of the slide, you see one of the swells, the upper swell is shaped, and further down a slightly different shade of gray, further down right at the top of the front one, is the second swell down, the one closer to the bottom of the slope. So the swells are all shaped. Then, like I said, this contractor came in and excavated at the low point of the swell in order to install the pipes. Here's a picture looking down. The two pipes are fairly close to final position. You see the Ys that are sticking out, one to the right, one to the left. They lead, the end point of these Ys are at the low point on the swells. One to the right connects to the low point of the swell to the right. The one to the left connects to the low point of the swell to the left. Same thing happens at the other Ys further down the slope. Here's a picture of the lateral chutes or the Ys. We covered the end point of it that the trash and dirt cannot get in it until everything is shaped and formed. Here is at the low point of the swell. In the foreground you see the swell body, the structure, and in the background you see the swell body on the other side. Eventually the gap in between them will be filled with dirt after the pipe are positioned right and to the satisfaction of the project specifications. Here's a kind of overview. The two pipes are in place. The Ys are the lateral chutes that connect to the low points of the swells. In this case we have two swells, so we have two sets of lateral chutes on the downshoot pipes. At the bottom end of the downshoot pipes are at the perimeter ditch. The top end of the pipes are at the temporary swell at the top of the partial closure. Again, another picture in this slide. You see the equipment has started pushing dirt over the pipe. The pipes are in the right position. Now they've got to cover the pipes with dirt. It's a very simple operation. You just assemble the part outside your project area, pull it and place it on where it needs to be in the project area, and then you push dirt on it. It can't be any simpler than this. Again, here the equipment is pushing dirt over the pipes, and the crew around that area is making sure the pipes are remain in position and until the filling is complete. Here the equipment is putting dirt over the pipes near the bottom in order to secure the pipes, and further up you see some dirt is already being pushed over the pipes. Looking down, you see part of the pipe is already covered with dirt, and in the center of the slide you see the two sides of the swell. Eventually the two sides come together, and where the pipes are, you will end up with a hump over the pipe, because we want to make sure that we have 2 feet of soil over the pipe, directly above the pipe, so we'll end up with a hump between the right and the left portions of this slide. This is the hump that is being formed over the pipe. The flags again is the top width of the hump is sloping at a 10-to-1 slope to the right side and to the left side. The reason that we make it 10-to-1 because we want to make sure that the mowing equipment in the future, when it's sodded and they come to mow the grass, they can easily get over the hump without damaging the slope. This is the upper part of the partial closure where the temporary swell will be located, and you see the two ends of the downshoot pipes at the temporary swell. Again, the same two ends, soil is placed over the pipe. This is the low point of the temporary swell. Now this is showing from the perimeter ditch looking up. The two outlet points of the downshoot pipes are visible here. Sod is placed over the slope, and the area around the pipe is not sodded because that area is going to receive the erosion control mat or fabric form. I'll show you that in the next few slides. Another way to do the piping is to put together or weld the pipe segments on the slope. In this case, the contractor is doing the welding directly in the trench where the pipes are going to be located. This is again the pipes in the trench between the two sides of the swell at the low point of the swell system. The welding machine is visible to the left, and they're putting pipe segments together with the Ys that are the lateral chutes at the specific locations. Another picture of that operation. The welding is going on near the center to the left side of the slide. See the lateral chutes already welded into the pipe system. The bottom of the downshoot pipes and at the perimeter ditch of the landfill. This is the two downshoot pipes are in place and in position, and the next step would be pushing dirt over the pipes. Now, erosion mat that goes at lateral chutes. Where the lateral chutes here, you see that the end point or opening to the lateral chute, in this case there are always two of them if you have two downshoot pipes. We normally cover the area around the opening to the downshoot with fabric form. And before we install the fabric form, we dig anchor trenches for the edges of the fabric form. This is the trenches that you see are the anchor trenches to secure in place the fabric form material. The fabric form is a prefabricated system. It consists of two layers of geotextiles prefabricated in the plant, and with the sewing patterns that leave kind of squares, interconnected squares at the between the two geotextiles. At this point, they're opening up or stretching out the previously folded package in the plant in order to lay the fabric form over the lateral chute area. Here the fabric form is being pulled over the area that's going to be installed. To the right side you see the opening to the lateral chute, and I think the anchor trenches for the fabric form are visible here. The fabric form is being installed in place, and the edges of the fabric form are pulled into the anchor trenches. It is near completion for the installation of the fabric form. You see next to the guy in the middle there is a orange color cross mark. That's the opening to the lateral chute. They're going to cut the fabric form there in order to daylight the lateral chute through the fabric form. This is again the cross mark is shown. That's where the inlet to the lateral chute is. The fabric form installation is near completion. Another angle of it. In this case, the fabric form has already been cut and pulled over the opening of the lateral chute. All of these are kind of fabricated, and the end point of the pipes are cut to the proper dimensions to make sure that after the fabric form is completely installed and filled with grout, there is no lip to the pipe. We want to make sure the water that gets on top of the fabric form goes directly into the pipe without any ponding near the opening to the lateral chute. And in the center and to the right side you see a dark color like a 3-inch hose extending from the upper part of the slope down to this. That is the hose that brings the grout to the fabric form. They're going to pump grout into this geotextile fabric form system. They're filling the anchor trenches with grout here in order to secure the edges of the fabric form. Then begin pumping grout into the fabric form between the 2 layers of geotextile. And since the squares that are generated by certain patterns of sewing between the 2 textiles are interconnected, the grout travels from one grid to another one, eventually shapes the fabric form as you see here. The darker side or the grayer side is where the concrete is already pumped into the fabric form. It's still going on. They are filling the anchor trench as well as pumping into the geotextile. One side of the lateral chute is completed. Now they're moving on to the next side, and as you see, the end of the lateral chute is extending out through the fabric form. Eventually they will cut the excess pipe and they flush the end of the pipe with the surface of the fabric form. Here is a picture looking down from the upper part of the slope. The second part of the lateral chute is being completed. It's a further stage of that grout pumping operation. The lateral chute is coming to the final stages of shaping and forming. Here is after completion. As you see here, the invert of the lateral chute is flush with the low point of the fabric form, so water flowing toward the opening of the pipe on top of the fabric form doesn't get ponded and can easily get inside the pipe. And behind the pipe there's a hump between the 2 sides of the downshoots and the 2 independent lateral chutes. Here is again another picture of it after the grout is set. Around the perimeter of the fabric form is not filled yet. At later stage they come in and fill the anchor trenches and shape the area around it. This is a picture looking down. Is a completed fabric form around the lateral chutes. The other lateral chute is not visible in this picture, but it's very similar to the one that you can see in the center of the slide. And to the right side of the slide you see the hump over the downshoot pipes. Now they're filling the anchor trenches with dirt in order to shape the area on all sides of the fabric form. Especially to the front side of the slide, they shape it that water can easily flow off the grass area onto the fabric form to the pipe. This is a picture looking down at the forefront of the slide. You see a fabric form around the upper lateral chutes. In the middle of the slide you see fabric form around the next set of swells and lateral chutes, and way down at the bottom of the slope near the perimeter ditch you see another fabric form that I'll show you at the outlet of the downshoots. Now, erosion mat at temporary inlet to downshoot pipes. Now we are going to go back to the top of the partial closure and show you the fabric form around the temporary swells. Here is where the fabric form will be located. Again, the invert of the pipes are flush with the top of the fabric form. And since this temporary swell can receive runoff from the active areas of the landfill or unclosed areas of the landfill, we kind of put a cage around these pipes in order to catch debris that may come down the slope. We don't want the debris to get inside the pipe, but we make sure that the operator is very well set up in order to clean this area on a regular basis, because we don't want too much trash around the cage and eventually water cannot get in and overflow this system and will damage the cover system. Let's see closely. The cage is in place, the opening to the pipes are visible, and the fabric foam around the opening to the downshoot pipes. This system that you see in front of you is a temporary system. Like I said, some years down the road, when we come in to install the next partial closure above the one that is completed in this slide, this fabric form will be taken out, the cage will be taken out, and the cover system will extend, and naturally the downshoots will be extended further up. Now, erosion mat at outlet of downshoot pipes. This would be at the bottom of the slope where the perimeter ditch is located. Here is the outlet of the downshoot pipes. The segment of the pipe that is sticking out doesn't have to be long. It could be cut back, make it shorter, however, it doesn't really matter. The area that the fabric form will be installed over is very well shaped and graded, and there's an anchor trench around that area that is visible in this slide. This is the anchor trench, and in the middle of the slide you see the hump over the downshoot pipes. This slide shows the fabric form where the outlet of the downshoot pipes are. The edges of the fabric form are already in the anchor trenches. The pipes are visible below the fabric form. The cut will be made in the fabric form in order to pull the fabric form over the downshoot pipes. Now the fabric form is cut, the pipes are sticking out, and everything is in place for the next step of pumping concrete into the fabric form. They start pumping. While they're pumping in the anchor trenches, they also pump into the fabric form itself. Again, the gray area, darker area, is where the concrete has already been pumped into the fabric form. Pumping is still in progress, and they make sure that on the sides the edges of the fabric form are well secured in the anchor trenches, and in the top area as well. More of the fabric form is filled with concrete now. They make sure that the edges are filled all the way to the bottom of the anchor trench and stay down, because we don't want the edge sticking up out of the anchor trench and be exposed to elements. And the concrete is finished. They have pumped the fabric form with concrete. Now they spray water over the concrete to keep it moist and for the drying stage of the grout. Looking down, the upper part of the slide shows the fabric form at the bottom of the perimeter ditch. The anchor trenches are not backfilled yet. Eventually they get backfilled. The two pipes are sticking out. You can clearly see the pipes. Any water coming out of the pipes will fall on the fabric form and then sheet flow off the fabric form to the perimeter ditch. This is looking at the slope. This is after the concrete is set. The anchor trenches are filled, backfilled, and the area around the fabric form is solid on the slope. This is the case after a big storm. This is the water that gets inside the downshoot at the swell system. and flows down to the perimeter ditch. Like I said, it's a very efficient and effective system. It is fairly simple in concept and it's simple to construct. This is another close-up picture of the water coming out of the downshoots. Since there is a fabric form at the bottom that the water falls over, there's no erosion created at the bottom of the perimeter ditch. Thanks for your time. I hope this information come useful to you for your future projects. And if you have any questions, please feel free to contact me on my email or my cell number 561-441-1473.